Hello everyone, welcome to another Algebra and Trigonometry. So today we're going to be simplifying some expressions, but it does look like they are polynomial. So what's probably going to happen for some of these is instead of having one term, one number, right, we're going to have something with a variable and something with a constant. There will be a plus or a minus between them. And these will not be like terms, so this will be the furthest we could simplify it. Probably a little bit confusing, but let's go ahead and work on some of these and let's work out the kinks, okay? So let's see what we have to do for the first one. So it's still a lot of order of operations, guys. Still a lot of order of operations, just including this idea of like terms, okay? So 13 minus 7, all right. Okay, so for this one, right, I see a times, I see a parentheses, and I see an add. So what we should do is the parentheses first still, right? So we don't know what x is, but don't freak out. It would just be like saying some number times whatever is in this quantity, right? Whatever's in this parentheses. So 13 minus 7, that's what? 8, 9, 10, 11, 12, 13, so 6. So x times 6, which is pretty silly, right? We x times 6 is 6 times x, so what we really have is 4x plus 6x. Okay, oops, I could write an x. So now we have what's called like terms, right? For this one, we have the same variable and it's to the same degree, the same power, right? They're both to the first power, so we can add these. So that's 4 plus 6, that's going to be 10x. And if you're wondering why the 4x is like saying x plus x plus x plus x, right? So we don't know what x is, but that's 4 times x, right? X plus x plus x. And then we have a plus here, and then it's like adding 6 more x's, right? Plus x, sorry, that's supposed to be a plus. Plus x plus x plus x. Already lost count. 1, 2, 3, 4, 5, 6. So if I count all these x's, right, 1, 2, 3, 4, plus 6 more, that's 10 of them altogether. So that's where this idea is coming from, guys, okay? So 10x. So we can combine like terms. All right, on the next one, let's see what we have. So we have 2y minus 4 squared times y minus 11. So the only thing that's getting squared is the 4, right? It's 4 squared times y, so it's not 4y squared. So what we have here for this one is 2y minus 16, because 4 times 4, right? 16y in this case, minus 11. So now we have 2y minus 16y, so that's going to be negative 14y. So these are like terms. We can combine them, okay? So there's y to the first power, y to the first power, so we just kind of copy y like a label, right? $2 minus $16 is negative $14, right? So it's just like a label for now. You know, it is some number, but I love to just look at them as generic labels. So I do the math, right? I do 2 minus 16, that's negative 14. I copy the y with it. And then minus 11. So this is it. This is all we can do. We can times by negative 1 and, reverse the signs, 14y plus 11. But, this is good. This is good. We can't subtract this 11 right now because there's no y, okay? So we can just add a y to this. So this is a two-term problem, right? This is what polynomials are, right? They have a variable to the first degree that won't combine with a constant, okay? Mm. Can you do this next one? Let's try it. Okay, so now we have a over 2/3, 2 to the third power, sorry, 2/3, times 64 minus 12a divided by 6. Okay, so these ones are a little bit trickier. So what we could do is say that's 64 over 1, okay? So that's 64a over 2/3. So what's 2/3? That's 2 times 2, which is 4. And then that's 4 times 2, which is 8. Okay, so that's going to be over 8. So I just simplified the 2/3 before I times it by 1. Then that'll be minus 12a over 6. And you might say, how did you get that? Well, a dividing b is equal to a over b. Okay, so a over b, right? A 12a over b. So and I like to look at it in this form because then it's factorable, right? So we don't know what 64 times a is, but we do know that we can simplify by 8s, right? These have factors of 8s. How many 8s fit in 8? 1, right? So if I divide both the top and bottom by 8, I get 1, right? If I divide this one by 8, I get 8. So what's left over here is 8a over 1. But 8a over 1 is just going to be 8a. Okay, so how many 1s fit into 8a? 8a. So move it up just a little bit. So that's 8a over 1, or just 8a. Now here we can factor out the 6's, right? We can say 6 divided by 6 is 1. 6 divided by 12 is 2. So we have minus 2a over 1, but how many 1s fit into 2a? Yes, 2a. So what we're really looking at is 8a minus 2a. These are like terms. They're both a's to the first power, so we can simplify them to be 6a. All right, so that's how we're starting to do some polynomial math. All right, how exciting. This is fun stuff, guys. All right. So next two problems we have are going to be 8b minus 4b times 3 plus 1. So we are allowed to multiply this 4 and 3. Okay, these are just one term. This is 4 times 3 times b, 3 times 4 times b, b times 4. So we can multiply however we want, right? We have the commutative property of multiplication. So 7 times 3 isn't just 21, right? It's also equal to 3 times 7. So 21 equals 21, right? We don't change it when we flip our multiplication. So we have 8b minus 12b, right? 4 times 3 is 12. b plus 1. So now we have 8b minus 12b, so that's going to be negative 4b plus 1. And we cannot combine these. They are not like terms, you guys. So 10x is the answer, negative 14y minus 11 is the answer, and then for this one, negative 4b plus 1 is the answer. So this constant doesn't have a b, so I'm not allowed to combine it with the negative 4b. Then last but not least, let's see what we have. So we have 5l dividing 3l times the quantity. I'm going to make them capital L's because they almost look like ones, guys, so that's a little confusing to me. Times 9 minus 6. Okay, so now we have 5l over 3l. And you're going to notice I like turning them into fractions right away. It just flows better. So 9 minus 6 times 3, right? So hopefully you guys are seeing we could factor out threes here, right? We don't need to necessarily factor out across, but we can. We can do 50 now. I'm not going to, so 5L times 3, right? So let's see how we can represent this for you guys. 5L times 3, right? Over 3L times 1, so that's just 3L. So here it's a little bit tricky. Okay, so what happens here is the L will cancel out with the L, right? We don't know what the L is, but don't freak out, right? You would say 4 over 4 is equal to 1. So if we plugged in an L, right, we evaluated for this, we would be putting the same value in every variable, right? So L over L is equal to 1. They cancel each other out, okay? And now the 3's are going to cancel each other out, right? If we divide L by L, we get 1. If we divide L by L, we get 1. We're allowed to do this because it's multiplication up top. So we could also cancel out the 3's, right? These also become 1's. So the L's become 1's. So now we have 5 times 1, 5. I'll rewrite it. So we have 5 times 1 on the L, times 1 on the 3, right? Everything over 1. So 5 times 1 is 5, right? 5 times 1 again over 1. So that would just be 5 over 1, and that would just be 5, okay? So a lot of steps that teachers can skip. You know, there's reasons why they skip a lot of these steps. They're very tedious, you know, but hopefully me explaining all these extra steps doesn't get you more confused. So, yeah, that's simplifying expressions, you know, in the form of a polynomial. Okay, so we have variables now. We can't always combine everything, right? A couple of key things we did see, right? Sometimes we'll just have the variable, right? A number with a variable. Sometimes we'll have a number with a variable and a constant. And then sometimes variables will cancel variables out. So quite a bit happening, I know. But let me know, comment down below if you got confused on any part of this. Um, Other than that, I hope this brought value to you guys. So like and subscribe if it did. And I will see everyone in the next video. Y'all have a great day.